Hi, today I'll be making a combination between this demo and this week's coupon challenge. What we have here are a number of arms. You can see a pink one, a red one, a yellow one, and so on. There are 9 of them, and each of them is a logarithmic spiral. If you have no idea what that is, I'll be linking to this page and you can check it out after the video, or you can pause the video and check it out, whatever. Anyway, the position of our dots, whatever you want to call them, on this spiral is going to be described using the polar coordinates of each dot's center. Now again, if you don't know what a polar coordinate system is, I will be linking to this page as well. But what you need to remember, the position of a point using the polar coordinate system is described using the distance from the origin, which is going to be the position radius, and the angle of this position radius with the horizontal axis. Now in our case in CSS, the positive direction for this angle is going to be the clockwise direction and not the trigonometric direction as in this figure, but it doesn't really matter. The idea remains the same. In the case of a logarithmic spiral, the radius, the position radius, is going to be a function of the position angle. So it's going to be a times e, the number e, raised to the power k phi, which is the position angle phi. And a and k are parameters, and as we code, I'm going to show you how they influence the shape of our spiral. But yeah, we should get to that, writing something. So we are going to start with the number of dots per spiral. Let's say that's going to be 20 initially. We're going to increase it, but for now we don't want to have that many elements. The number of arms, or number of spirals. So each arm is going to be a spiral, okay? Then we are going to set some parameters. Let's say that a is going to be initially 50. Let's say that k is initially going to be 1. And we are going to set one more parameter. And let's say that this one is going to be 18. And you're going to see in just a moment why we need that. Let's start computing stuff. First, the total number of dots for our demo, and this is going to be the number of dots per arm times the number of arms. Then we are going to compute a unit angle, and this is going to be 2 pi over v. So basically this is going to be our unit angle. For each of the dots on our spiral, its position angle is going to be its index times the unit angle. So for the first one, its position angle is going to be 0 times u. For the second one, its position angle is going to be 1 times u, and so on. Okay? And knowing that, we can of course compute the radius. So yeah, we know both r and phi for each of our dots on each spiral. Okay, good. So knowing that, we are going to compute a few more things. First, we are going to compute e to the power k times the unit angle. K times the unit angle. And that's because, let's get back here to this formula right here. So for the first dot, its radius is going to be a times e to the power k times 0 times the unit angle. For the second one, it's going to be a times e raised to the power k times 1 times the unit angle. So basically, for every, let's just write it here. So for the first one, the first radius, r0, it's going to be a times e raised to the power k times 0 times the unit angle. Now this is just going to be a, because anything raised to the power 0 is going to be 1, because it's a times 1, so a. Okay? Now for the second one, it's going to be r1 is a times e raised to the power of k times 1 times u. So that's going to be a times e raised to the power k times u. So that's going to be a times m. Now for the second one, the third one is going to be a times e raised to the power k times 2 times u, and this can be written like this. It can be written as a times e raised to the power k times u plus k times u, because this is 2 times k times u, okay? And this can be written as a times e raised to the power k times u multiplied with e raised to the power k times u, or a times m, okay? And by the way, this is also a times m raised to the power of 2. So in general, Rj is going to be a times m raised to the power j, okay? So that's why we need that m value. That's the generic formula. Now, not here. I want to show you something here. Let's consider this point on the spiral and this point on the spiral. So those intersections with those radial lines, right? Those 2 points. As mentioned, we can compute this radius, we can compute this radius, we know the angle between them. So let's consider that those are 2 consecutive dots on our spiral. We know that this radius is the previous radius, the one from here, times that m value, right? And we know the angle between them. In this case, it's 45 degrees. In our case, is that u angle. So this means that using the law of cosines, we can compute the distance between these 2 points on the spiral, right? Now, let's say that we compute the distance between the very 2 first points on our spiral using the law of cosines, which says this: the third edge in a triangle squared is the sum of the squares of the other 2 edges minus twice their product times the cosine between them. In our case, the cosine of the angle between them is the cosine of u, the unit angle. So our distance between the first 2 radii, between r0 and r1, is going to be d. We can call it d0, but we're going to call it d because we don't compute it for the rest. So it's going to be square root, right? The first radius is a, so squared is going to be a times a, plus a times m is the second one, times itself, because we square it, minus twice a times the second radius, which is a times m, times cosine of the angle between them, which is u, right? So we can take out a times a, and outside of the square root is going to be just a, so we're left with 1 there, and just m times m there, and just 2 times m times the cosine there, right? Okay, so we know this is the distance between the first 2 radii, the first 2 dots, sorry. Now, we've used the term radius, and until now it's always been used to express the position radius. So the distance of the center of a dot, the distance from the origin right there in the middle to the center of a dot, right? So that's basically the position radius. But we have another radius, which is the dot radius. And the distance between two consecutive points on the spiral, which are the centers of our dots, we can compute it using the law of cosines, but it's also the sum of the two consecutive dot radii, which we'll be calling C something. Okay, so basically we know that D is the first dot radius plus the second dot radius. Now we also have the fact that C0 over C1 is R0 over R1, okay? But we already know R0 over R1 because R1 is R0 times M. So it's R0 over R0 times M. So basically this is 1 over M, okay? So basically we can say that C1 is C0 times M, which means that here we have C0 plus C0 times M. And this can give us the radius of the very first dot. And we are going to call it just C, not C0, because we don't compute it for the others as well. So this is going to be D over 1 plus M, okay? Because basically here we're going to have, right, and we can get it out of there. Okay, so knowing this, we can start setting a few things right here. So we are going to have the body, and in its style attribute we are going to pass a few things to the CSS, the number of dots, the number of arms. So the number of dots per arm, sorry, this is CSS, right? The number of arms okay. We are also going to pass the unit angle, and here we are going to use degrees, so it's going to be 360 over V degrees, right? And we are also going to pass that M value okay, and we are going to pass the first radius, the first dot radius, right, and the first position radius, which is going to be basically A. Okay, now having done this, we are going to set a few things in a style element, but first let's create our dot elements. So right here we're going to have a loop, so for let I going from 0 all the way up to the number of arms, increment this I, and we are going to have that dot nth of type, okay, and here we're going to have after all the dots on all the previous arms, so we are going to have I times the number of dots per arm plus 1, and +1 because this nth of type index is 1 based as opposed to loop index, which is 0 based. And here we'll be setting the arm index to the loop index. Now we're going to have a second thing right here, and here we're going to have we're also going to set a factor, and this factor here is going to be m raised to the power of the loop. This is going to go to the number dots, okay, and this is going to be every n dots, so for every arm, and this is going to be the index along the arm j. Okay, so that's basically what we need. Now let's move on to the CSS and put some stuff on the screen. Yeah, I can't use a keyboard. Anyway, we'll be setting display grid on the body, place content center, make it full height, so that okay, let's get rid of the scroll bar. That's because we have a margin on the body, so if we zero the margin, we get rid of it. Now for our dot elements, we are going to have place self center, and its padding is going to be calc, and it's going to be that first dot radius, the initial one, times the factor. And let's set box shadow something like that. Okay, grid area, we want them all stacked one on top of the other, so they all occupy the same cell at the intersection between the first row and first column. And one more thing I want here, set overflow hidden. Okay, now we are going to set transform, and as I said, we're going to have rotate, and our rotation is going to have two components. One is going to depend on the arm, and this is basically the arm progress, and it's going to be the arm index I over k, the number of arms. The arm index over total number of arms. So here we're going to have k times one full turn, and then we're going to have the component along the arm, which is going to be the index along the arm times the unit angle. Okay, and then we're going to have translate, and here we're going to have a, so the radius of the very first dot on each arm, times that f factor. Right, so we are going to start seeing something there. Let's set a background. Let's use an HSL value that also has the hue depending on that arm progress. So we have a different color for each arm. So something like this. Let's max out the saturation and have midway luminosity, and now you are going to see them distinctly. Let's also make them more dot-like. Border radius 50%. Okay, so now you can see how they're nicely arranged. And I said earlier that I'm going to show you how the shape of the spiral depends on these A and K parameters. So for example, with K, the bigger it is, the more it grows outwards, and the smaller it is, the more it wraps around. So let's say it's going to be something like 0.5. you can see how it wraps around a bit more earlier on. So let's say we're going to have something like 0.25. They're going to wrap around even more. Now we get a bit of overlap, and we don't quite want that. And you can see how it looks pretty nice. And this A value, this controls how big the first radius, the radius of the first dot, the position radius of the first dot is going to be. So for example, if I make this 24, it's going to be quite a bit smaller, you can see. Okay, so now, having done this, let's have an animation. So we're going to want each of these dots to animate to the position of the next one, and also to the size of the next one. So the position of the next one means adding one more unit angle there, means multiplying this position radius with m, and it also means scaling this its size by m. So we are going to take this keyframes, animation, and we're going to go to, going to have transform, so something like this. And here we're going to have j+1. Here we're going to multiply with m, right? And we're also going to scale to m. Now let's see how that looks. 1 second. Linear, infinite, it's kind of looking okay, kind of. You can kind of see a bit of a jump for some of those, see how they jump at the end of the animation. And of course you have those disappearing, and we're going to make them disappear with opacity. So let's say that here we have opacity, right? And it's going to be calc 1 minus j over the number of dots, right? And here we are going to have j+1. So you can see how the last one, we just have that one dot just appearing there. So here we're going to add a scale that's going to be the minimum between 1 and j. Now this is going to be 0 for the first one, which has j0, and it's going to be 1 for all the others. And you can still see that tiny shift, right? And that's because of rounding issues. Now let's just look at the compiled HTML here. So you can see those values, right? Now the thing is, this is m raised to the power 1. This is m raised to the power of 2, m raised to the power of 3, and so on. Now the problem is that this value, m raised to the power of 3, won't exactly equal m raised to the power of 2 times m, because of rounding issues. So we get those tiny little jumps, and they're barely noticeable, I know, but they still bother me. So the solution I found was to just pre-compute the initial and final radius. So we are going to set a radius and a scaling factor. So we are going to have the initial radius is going to be a, and the scaling factor is going to be m, right? And here, this is going to stay the same. We are going to set the first radius, the initial radius, r0, and this one is going to be the radius we already have, pixels, and rounding it. We are going to have the initial factor, f0, which is going to be f, right? And then we are going to have the final radius. Sorry, it's a custom property. And this one is going to be like this. Okay, pixels. And here we're going to have the final factor, which is going to be the previous factor times m. Okay, so knowing this, here we are just going to have that initial size, and here we are going to have the initial radius, r0. Of course, here we're going to have r1, right? Here we're going to have f1, and here we are going to have a calc value, which is going to be that, right, times the f0 factor. And now it looks a lot nicer, but again, due to rounding issues, those appear bigger. So I think also we have some really ugly numbers there. So let's fix those. So here we are going to say, so we reduce the ugly number of decimals here as well. All right. And here, let's see it. Okay, so now we don't have that ugly overlap anymore, and we can prettify the thing. So let's say that we can set a background here, and let's say it can be a radial gradient from black to white, and let's say that it's going to be circle closest side, something like that. Okay, so we can have something like that, and we'll be able to collapse the body, collapse that set of keyframes as well. Let's prettify those colors a little bit. I suppose something like that. And let's play with those parameters to get something slightly different. Let's say that we're going to have more dots per arm, I don't know, 50. Let's say that we are going to also increase this, so we have more dots like that. I don't even know. Let's say that we're going to decrease this as well, so they're a bit more closely packed like that. So yeah, I don't think I'm going to tweak it much more. I think I'm going to leave it here. I hope you've enjoyed this video, and if you have, if you like the work that I'm putting out since early 2012 and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon. Or if monthly support is not your style, there's the option of a one-time donation, or you can make me happy with a gift off my wish list, or you can at least share this to show the role what can be done with CSS these days. In any event, thanks for watching, and the links for everything are going to be in the description, and I'll see you next time.